Hi folks, uh, welcome to the end, or pretty much the end, of the big amplifier project. This is a picture here that I'm going to talk about a bit. I'm using a little bit of a new format here. This is a screen capture and camera combiner thing. Really simple, makes good reports. So instead of walking around getting everybody seasick with a video camera, I thought I'd give this a try, at least for this part one. Well, maybe for both parts. So in part one here, I'll just kind of show how this thing worked out. And in part two, I may talk a little bit more about some of the technical aspects that I worked out that worked well, and some of the ones that didn't, that got replaced. Anyways, this is the boat anchor AM end of my shack. You can see on the right, the yellow mouse here, I move around here. This is the new amp. And this is the Viking 2, Johnson Viking 2 that I rebuilt a couple of years back. Came from Ray there, BFW, and I think previously that Fred had this. I can't remember, but anyways, I'll just bring that in a bit. That got rebuilt, and that's my exciter for this amplifier. Primarily, this is going to be my 80 meter amp, but it loads up perfectly on 160, 80, 40, and 20. I doubt I'll ever use it on 20, but it'll go there. And I'll talk about the limits there in a minute. The rest of the operation here is receivers that can be patched into either the Viking or on the left over here. I've got my other homemade amp. Let me move some of these around here. This is the 3500Z do-it-yourself amp. I built the homebrew guy that I used to use with the Viking, and now it is a amplifier for this Yaesu transmitter over here. So I kind of leave this on 40 meters, and I'm hoping to have a little audio chain processing connected to this very shortly to use with the D104. And over here on the big guy, I have a Chinese studio mic, a Neewer. They work really well, very low cost, and a studio mixer processor, a DBX 286. Can't remember the number. Does everything you need. And unfortunately, I do need to maintain a little bit of an attenuator between the Viking and the amplifier, because this thing is so efficient, so much gain, that it doesn't need much drive. You can drive it to full power with less than 10 watts. So in order to get the modulation levels right on this guy, which uses a pair of 6146s in the output, I have to run it a little bit higher than 5, 6, 10 watts. So I run it around 30 and put it through an attenuator to drive the big amp. Everybody's happy. The receivers are Harris shipboard naval receiver from back in the 70s. I fished this out of a dumpster and rebuilt it, and it's a really nice receiver. It works really well. Interesting that it's solid state, but it has one of the very early 8085 single chippers in it with a outboard ROM, and that board was all blown up, but I managed to fix it, and the software still works. So it's a nice receiver. I've got a really good condition R390A, and of course this CSR5 that was also tossed. Fred gave me this, and I rebuilt the thing completely, and it works quite well. Now actually, it's a pretty nice receiver. I rather like using it. Anyways, I can bring all three of them into the either transmitters connections for mute and receive audio in this little patch panel here. Anyways, enough of that. So the amplifier is heavy, big, sits on a little roll around base in case I have to get in behind it, but I don't have to get in there very much. So it has 5 modules that bolt in from the front here. 5 module covers. Several modules do insert from the front, but the bottom one is just a cover over the high voltage power supply. So the transformer, the big choke, the capacitors, rectifiers, everything are down here. This little panel here has inlet circuit breakers, main switch, and some power distribution, and a line filter, a EMI filter. This is the control module here. This is on drawer slides, so it slides out in front of you and you can operate the whole thing while it's open and do testing, and I'll show some pictures of that. This is the RF deck where the tube and the grid compartment, tank, and everything live, and the blower. And this little guy on top has metering that came with the original amp. This thing originally was a Gates FM 1K 1 kilowatt FM transmitter. I guess they built zillions of these. Most of them have wound up in the trash, but some are still operating. And a few, probably more than a few, have been acquired by hams and built into some pretty decent amplifiers. So anyways, I got this one from Derek, VE1AWT, and I keep getting his call sign wrong, in Dartmouth, who's getting in there and decided to start, doing some cleaning up of his unused gear. And I thank him a lot. He donated the chassis for this thing to me, knowing that it needed some rebuilding, which it did, probably more than anybody expected. Anyways, I completely dismembered the thing. I mean, completely, and redesigned everything, basically everything. Power supply, all new controls. The RF deck's been completely re-engineered, and it works really well. I'm quite happy with it. So I may look for a better, more detailed picture here to get in closer. So stand by here. I'll be right back. Still not a really good picture, but I just kind of indicate the controls a little better here. It's on in warmed up condition at the moment. I will do a little bit more detail on the control panel here, but basically when it's operating, I've got two above the circuit breaker here. There, above the circuit breaker, there's a pair of neon indicators there. So that's the line input, the 240 line input. So if either line's out with reference to the neutral, that'll show me. When it's on, that feeds the system and the breakers, or the interrupters, the relays that feed the high voltage primary. But also they feed a pair of smaller fuses that provide auxiliary AC into this control deck for filament, fans, control power, stuff like that. So these little LEDs here indicate that the fuses for that are okay. This little green light here is only on sitting on a current transformer on the filament line. It's not hooked to anything else, but as long as there's current going to the filament, that's lit up. This yellow light's very important. It comes in the output of a ORD logic fault system. It starts with the airflow switch. So there's a sail switch in the output of the blower in the grid compartment. So if for some reason the blower quits, that won't come on and it won't allow anything to happen on the amp. But there's other faults that'll trigger the fault system as well, including overcurrent in the screen or the grid. A couple of other things. But basically it interlocks a few other things. So if anything goes wrong, but the primary ones are the air being off, so there could be instant overheating, and the grid and screen current being the most important one. Now I'm driving this thing in tetrode mode, and so there's no current that flows in the grid. I mean, so little you can't really measure it. So if any current does appear there, you got a problem. That means the tube is going wrong. So it senses that, but the screen current has optimum values. So if you go over them, that's a problem. So that's more sensitive, and that's where a trip happens. If there's a fault, it immediately shuts down the high voltage input, but of course it has to drop down through bleeders, so it'll take a few seconds to dissipate. There's an enable switch here that's only going to allow the push-to-talk or keying system you got hooked up to it to activate the amp, so long as all this fault stuff is okay and there's no there's a green light here. And if you do have a fault, this little red fault light will light up and flash, and there's a reset for it right there. You can just instantly reset it and try it again if you want. You probably aren't going to hurt anything, but it won't operate if there's a serious fault. These little switches here are to switch this grid meter between screen and grid. G2 and G1. Usually you leave it on screen, and this guy switches the built-in power meter between forward and reverse. On the RF deck, a little closer here, we got your tune capacitor, load capacitor, and then I didn't have a switch big enough to combine them, so I've got one switch to switch the inductor in the tank and one to switch the loading caps that I need because this capacitor is not big enough. It didn't have enough range in it. So I've got a bunch of loading capacitors for each of the bands. I modeled the thing with using the very accurate substitute output impedance, and you can make this whole thing work dry by basically using a resistor clipped across the plate to ground on your tube when it's not powered. That is that output impedance. So you can look backwards with to the antenna input with an analyzer and bring everything to 50 ohms. And that's how you check to see if you got everything right. And this one is really good. I haven't had to adjust the output, the load capacitor yet, because the values are so accurate for each of the 3 bands I tried it on. But if the antenna gets way off 50 ohms, I will have to, of course. This one here doesn't hook up to anything. That's an input rotary switch in the grid compartment in case I ever decide to put tuned circuits in there. I just put it in. I said, well, might as well put it in. I had the switch and everything, so I'll probably never use it. I have a direct drive broadband input. It's flat right up to 30 megs. I don't have to do anything to it. And this little guy on the right here, well, big guy, is a output selector. So I've got 3 output things. One's got a dummy load on it, and I got a choice of 2 antennas. I only got 1 antenna on it right now. And then above that, of course, are the meters. So there's the usual grid and screen meter, one for the plate current, one for plate voltage, and the RF output meter here. It's kind of loosely calibrated in watts. So there you go. Those are the modules. Now, what's interesting, of course, is that this guy pulls out. And let's go to that next. I'm not used to controls for this thing yet. Give me half a minute. So here's the control drawer slid open here. So everything you need is, you can just kind of sit on a chair and look down into this thing and get at everything you need. So what's in here are the 2 G3 SEK style Tetro control boards. They're no longer available, so I had to make these from scratch. And they work fine. And I do have router code for that, so I can make more. I made mine on 4x6 cards, I think. So one basically has got power supplies and the grid controls, and the other one has the the logic, the switching logic, and the screen supplies. Also in here, there's a little panel here with all these little tip jacks on it, and you can stick a voltmeter on here. I'll show you a picture of that, and measure everything that's important right here. You can see this bias and grid voltages, the input to the power transformer, the input to the high voltage transformer, the sensor signals from the high voltage bleeder and from the plate bleeder in the power supply. There's a little fan power supply over here, and at the back, looking down on this chassis, I have a picture of that somewhere, but there's all solid state relays to do the switching. So it's very convenient, very easy to work on it. This is a picture of the door at the back during construction of the door off, but you can kind of see how things lay out here. This is the high voltage compartment down here. It's all sealed up. There's a shelf above it, and of course the front panel, so you can't get any pinkies in there. There's a high voltage line that comes out of the RF deck and has a safety plug that plugs into the HV supply. It's one of those long, proper things for high voltage, so you can actually pull it out while the power's on. There's no danger in doing it. This is the RF deck here. This is the back of the control unit. It's in its home position right now, but you can see the relays and some of the swamping resistors and stuff here. These are soft starts, and over on the right there's a screen shunt system that dumps extra voltage and stuff to resistors, but it clamps the screen voltage hard. I mean, it holds it really well. Underneath here, and I might have a picture of that. Oops, let's go the other way. There are two Variacs sitting on this shelf. This, you see, you can get at them with the control panel slid out front. So you can reach in and adjust these if you need to. But basically, they adjust the primary voltage on the high voltage transformer. I found if you put 240 on it, you get 4,000 out of this thing. It's too much. Might have been okay for FM use, but not for AB1 use, where I've got this thing biased. So I got them set down to 190 volts, I think. And each one is hot to neutral. So the two of them together add up to your primary voltage. And that gives me 3,400 volts no load and 2,950, 3,000 under load. So it's just perfect. Let's go back the other way. Yeah, so up top here, this is still part of the original equipment actually. This box is sealed up all around, and it's the grid compartment. So it has the tube socket sitting on this side, and I got some pictures of that we'll come to later, or in the second report. And I contained all this in aluminum here because there's high voltage in here, and I wanted anybody to get at it. And there's a blower. The blower for the tube is actually inside the grid compartment. It's a pancake blower, a new one, and it works really well. So there's a hole cut in the end of this thing, and it sucks in air and blows it through the tube. And this guy here is a little box that includes the switching relays, the transmit receive relays, and a pickup for an REA modulation monitor. Steve's REA company, I got one of his modulation monitors. Works really well. Very pleased with it. And this box up top is behind the meter panel, and it's all enclosed. Better picture of the unit while it's in standby mode there. Actually, it's in enable mode. I see the switches up. So you can see up top there, I used a little Icom 706 to test it, and I had this thing cranking right up to the, I mean, way over the limit, the power of 10 watts input. So it's got lots of gain. The tube data sheet suggests, the IMAX sheet suggests you limit this thing to 1600 watts peak envelope power, which I'm doing. But I think in the FM service, they allowed this thing to go substantially higher. And the high voltage supply is too big. So I had to figure out a way to reduce it, which I'll show you. And so I try to keep the operating voltage, plate voltage down to 3,000 or less. And the current is well within the spec. And I operated on AM around 400 watts carrier, and that equates to about 1,550 to 1,600 watts peak envelope power. So it's perfect. And it gets barely warm. I mean, it warms up, but on long chats, but long talk sessions. But it's, I don't think we're overdoing the tube at all. 4CX1000 is an interesting tube. Oh yeah, one little thing I found out about it. I had the double zone time trying to figure out why the screen current would be negative under certain conditions. And it turns out this tube is famous for it. I thought there was something wrong. It turns out there isn't. But this tube is well known to have negative screen current, small amount, during idle and low power. And then at some point it drifts over into the positive region, which, you know, equates to more power. So it's kind of interesting. It threw me for a loop there. So it's not an issue. And yeah, it's a little better picture of the thing. So find another picture for you. I got a few construction pictures here to look at of the power supply underneath the high voltage power supply. This is not the right Variac that I wound up putting in there, but it's one I had around for size. It's the right size. I found Variacs are low price these days. I got two kilowatt Variacs on Vevor Canada website for like 115 or 120 bucks each, sort of thing. They were really cheap. Great deal. So this is the front looking in. So there's the Gates high voltage power supply. Beautiful, I mean transformer. Beautiful high voltage transformer. These two are poly filled high voltage capacitors that came with it. and I added 2 more in the output. I'll discuss that circuit on the next video. That's a bleeder for the voltmeter, and that's the current series resistor to get a current low voltage current signal for the plate current. There's a high voltage choke here. The thing came with 2. I only used 1 of them. That's closing in the compartment from the back. See the shelf here and everything. There's the high voltage connector, etc., etc. Picture from the front. You can see, well, you can't, I'll move around the front. So this transformer up the front, that's a filament transformer. There was a spot for it there, so I left it there. Those are also made by Gates specifically for these tubes. So like I say, they must have made a zillion of these transmitters with 4CX1000. There's information in an IMAC note I saw somewhere that the 4CX1000A was originally developed for FM use. And of course it had really good characteristics on HF AB1 use too, below 100 megs. But I think they sold most of them into the FM service. Oops, there's the back of the drawer system there. I don't think the drawer system's installed yet, the slides, but they sit on the sides here for this control chunk here. These are all construction pictures. There's the proper Variacs that I wound up getting. I had to put these wooden spacers in to the rack in order to mount drawer slides for this thing, and I took a bit of fiddly stuff to get that right. And of course I used furniture grade walnut for that. I just happened to have a piece the right size. That's the old control deck. You see, I took everything off it and covered up stuff, you know, put new aluminum on it. There's the slides. There's the drawer slides installed. That's the mains wiring, the circuit breakers. So the control deck sits just above this. You see, it's all kinds of room. It worked out really well. That's that little voltage sensing panel, voltmeter plug panel I put into the control deck. It's Autumn. His nemesis is that vacuum cleaner. He does not like that vacuum cleaner, like most dogs. And of course I did a terrible thing. I parked it on his mat, so he's giving me stink eye there, you know. Despite his effort, he's not friendly with a vacuum cleaner. They did a pretty nice deal. They came with heat sinks. These things get warm. They have thyristors in them, so they have to be mounted on heat sinks. I have 5 of them in there. 2 are the high voltage primary. 2 are the inrush limiters, and this heatsink here has a FET on it, a hex FET that's used to provide the shunt regulation of the screen supply. And then you can't really see it, but there's another contactor just out there, which is the filament current contactor. They're just looking down a bit. So these are the G3 SEK boards that I built. This is my little, I also built this. This is the peak meter board. Reads two sensors and it does a peak reading system. Has a sample and hold circuit, and you can calibrate your meters with them. I've been making those for years for all kinds of cross meter needle systems, but you can use them on any system really. These are power supply transformers for control voltages over here. This thing got a lot uglier once all the wiring went in it, of course. So there's the contactors and the filament contactor. I don't think anything's mounted here, they're just sitting in the chassis. There's the sail switch. Grid compartment. There's a picture without the dampening material on it. That's the pancake fan. Very happy with that fan. It's got nice ball bearings in it and everything. Brushless DC motor. Quite nice. That's that sound deadening material. There's a roll of it. You have to buy that roll. It's messy stuff, I can tell you. And you really don't want to be taking it on and off. You want to get it sorted out so you stick it on and stay in there. Like I say, it's designed for automotive applications. More fun and excitement on the workbench and wiring. It's underneath. It's mostly transformer wiring into there. Yeah, it still doesn't look too bad there, but I can tell you when I was done, this thing was pretty messy. But you can take the front panel off and fold it down on a bench. You don't have to disconnect all the wires, so that's a nice thing. But if I ever had any reason to change anything in here, I'd probably take some of this wiring out and do it a little better next time. But I don't need to, but I might. Started off with good intentions though. All the wires are tagged with heat shrink tags, all ends, so that's important as hell, really. There's a little circulating fan to keep air blowing around these heat sinks on the contactors, solid state contactors. That's looking down on the control deck there. What's missing? Oh, the little board with the soft start stuff and the meter board. Yeah, there's nothing important there. That's my 3D printer. Okay. Let's kill that and we'll go find some more pictures. There's some construction pictures of the RF deck people might be interested in. So while it was out getting mechanical work done to it. So this is the back here. And you can see the tube is mounted in the socket. And there's the chimney there. This is the grid compartment on this side. So just flick through some of these. I'll just stop if there's something interesting to look at. This is all drilling and blasting, as we call it. There's some looking down on the coil. Tank switch there, the inductor switch. Plate choke, the national plate choke. Oh yeah, there's something interesting here. So the plate capacitor is sitting on top of the load capacitor, but there's actually a steel plate between them to lessen the influence of mutual capacitance changes, you know, that could affect either one of them. And then there's a shield that drops down, a U-shaped shield that drops down over this one. So it keeps it kind of isolated and fairly free of extraneous effects from the chassis. That's the inside of the grid compartment. That's the ceramic chip-sized dummy load. That's actually a 200 watt 50 ohm dummy load on that heatsink. I don't need it, but that's what I had, so I stuck it in there. So that's a swamping resistor, because we don't use any power from the exciter. It's just voltage. This is the padding capacitor network down here, and this is the safety choke on the output. Normally it's like 3 millihenries or something, so it's not this is the output, comes to the padding capacitors here, and then this goes out to pickups. But normally this isn't seen by the load here at all, the low impedance load, but if this ever gets DC on it, it'll flow through this thing and create a dead short. There's a fuse in the power supply, in the high voltage power supply, that'll blow. That's the back of the tube socket. There's the wiring for the tank coil. Looking down on it. This is all copper strips. I've settled on this long ago on a couple of amp projects. Makes really nice wiring for an amp. It's easy to move, easy to fix. It's really sturdy, it's solid, low inductance. I wrap it up with a double layer of Kapton tape just to reduce the, increase the dielectric strength, if you like, to air or, anything blowing by it. Some of the wiring happening in there. This is not in there now. Like I say, I have a entirely different input circuit. Yeah, it's working out in the shop. They're doing work. That kind of chaos follows this project kind of thing around 24/7. You know what they say, a clean bench is never used. There's the high voltage fuse. So that's a microwave fuse. You got these on Amazon. So this plastic holder snaps open, and there's an interesting long cartridge fuse in there that are used in microwave ovens. It's really perfect for the sized linear power supply fuse. I've got it on 2 standoffs here. This the high voltage cable, an insulated one, comes out of this grommet, goes to the fuse, and then the cable comes around and runs over to the plate choke. It's a little dizzying there, but that's kind of looking in with the back door off of the grid compartment, so wiring's all done there. Wrong network, that's not the final network, but gives you an idea. There's the blower mounted on the cover of the grid compartment on the inside, and it's been soundproofed here with that soundproofing material. These are pancake blowers. Really works well. They come with their own little PWM power supply, adjustable speed control, which, by the way, you have to choke up a bit because it radiates quite a lot of receiver noise. But I found a couple of chokes on the lines, killed it. This is the sail switch. I wound up making this myself because I wanted a normally closed and a normally open contact. And I couldn't find one. You can buy these online. They're used in air systems and furnace systems and stuff, but I couldn't find one with both contacts, so I had to wind up making one. Anyways, it worked really well. A helper, patient. Let's look in the back of the tube socket. That's the cover in place. This is a piece of stainless screen to keep isolation, RF isolation, so I don't have any kind of feedback issues in there. And that's the quick, there's a door. This compartment was part of the original Gates operation. And it's got quick turn connectors to remove the door so you can kind of look in there and see what's going on if you ever need to. This is the watt meter pickup, the first one I did. It worked, but I made a mistake and put it in this box with the modulation pickup and the transmit receive relays. That was a mistake. So I wound up taking it out and putting it outside. These lines go through the chassis, and they're all on connectors, so you can pull this whole box off with 2 screws. You just undo the screws and undo the RF connectors, and you can pull it right off the chassis to work on it. There it is there. So it sits over this hole here. It's where the leads go. And there you go.